Hi, everyone. Welcome to today's stream. I'm really glad that we have this first innovation coffee on robotics. And I'm excited to have a couple of guests with us today to talk about specific and really cool projects that they've been working on lately. So let me bring in our first guest, David, also known as iShotJR. Hi, David.
Hi.
Welcome. Welcome on the show.
Thanks.
Really good to see you.
You too.
How are you?
Pretty good.
Cool. So for everyone's sake, I guess I wanted to introduce David. I've met David a couple of years ago, right, David?
Yeah.
It was a couple of years ago when we met on an online contest that David took part on. The really interesting thing about David here is that actually he's one of those amazing people that always works on a lot of cool projects, and probably in a lot of cases he works on a lot of cool projects all at once. And I always ask myself, how is that possible? But yeah, I mean, it's amazing all the work that you've done in the past couple of years, at least from when I met you. One interesting thing, I think, that before we go into the robotics section, I want to talk a little bit more about yourself. Let's start with, I guess, who you are, how you define yourself, if in any way, and then we'll go on from there.
Sure. So my name is David. I also go by iShotJR, mostly online. As far as how I define myself, I guess I'm kind of a maker. My education was in computer science. I went to the Honors College at the University of Michigan. But when I was in school, I wasn't really interested in hardware at all. I thought hardware was kind of boring, and software was where it's at, because all the cool stuff happens on top of the hardware. Let someone else build that. But then when Arduino and Raspberry Pi started coming along, and the maker movement in general started coming along, that was something that started to fascinate me. I actually have here my first Arduino. I just happened to find this the other day. It's from 2007. I think it's a D'Amelio prototype limited edition. So yeah, I started hacking on Raspberry Pis, and actually Roombas was what really got me into the maker stuff. Was a book written by Todd Bot, which I happen to have over here too, about hacking on Roombas. And so I got really interested in the idea that you could hack on these things. And so yeah.
We have someone noting.
Go ahead.
Sorry to interrupt. No, I was going to say, we have someone noting that you've got the secret identity that now you've
I usually keep David and iShotJR are usually kind of separate, but it's okay. For you guys are all special, so you get to know. But yeah, so I'm not an electrical engineer or anything like that. I just get really excited about lots of things and then figure out whatever I have to do to make that thing happen.
Cool. I mean, that's, yeah, as I said, I think when I met you, I've realized how many projects you can work on at once. And it's always been surprising to me. I wanted to ask you a couple of, look what we got there.
That for some research.
Yeah. Matrix Labs. Our friends from Matrix Labs are on the show, so that's cool. I was gonna ask you a couple of questions. I mean, we're not going to talk about COVID-19 here, because we don't want to turn this into a medical show or anything like that. But I'm keen to ask you, from a human perspective, how have you adapted to this kind of new situation? I imagine you're working from home like all of us. How have you changed your setup, if in any way? Has anything changed, and how are you keeping up your daily work?
Yes, so I already, before the pandemic, was working half from home anyway. So this is my home office. I have a pretty awesome setup. I have all the things I love in this 100 square feet or whatever it is. All of my current computers, a lot of my projects that I'm working on, 3D printers, retro gaming stations, music production stuff. So I'd be happy just, if I didn't have to eat and talk to my family and things, and I'd be happy just being in this room for 10 years, no problem. So it hasn't impacted me that way. But at the same time, I've definitely been thinking about how I can use my skills to try and help with the pandemic. The Fold for COVID program, shout out to those guys. That's something that's I've been really interested in. I was there from one of the first days, I think, and I've been trying to work closely with those guys to make sure that thing works on some devices that it wasn't. Our local makerspace, All Hands Active, I'm working with them because they had some 3D printers that weren't really working, that I thought maybe I could fix them up and get them printing some face shields. So I've really been thinking about, instead of hacking on my silly projects like adding a keyboard to a Pebble smartwatch, what can I do to help with the pandemic, even though I'm not any kind of medical person or anything. And another great example of that is the Hackster contest. I have my Hackster t-shirt on. They have a COVID based contest with tons of amazing partners who are providing hardware and other inspiration for that. So I'm also participating in that.
Cool. Yeah, so as I said before, you are participating always in a lot of contests.
Yeah,
and
I try to do every single Hackster contest, and every single contest I find out about pretty much. And that's just like 10% of what I do.
Yeah, and it's, I guess, is it a good way to learn new skills and new...
Absolutely, yeah.
Yeah?
Yeah. So I'm always like interested in, machine learning at the edge or whatever, and then there'll be a Hackster contest. Like there was a Spark Fun contest that was exactly that, and got a chance to play with their hardware. And so for me, Hackster is, I mean, it's great when I win prizes. I've won some cool stuff like Oculus Rift and things like that, which is great, but that's not why I do it. I do it because of the exposure to the new technologies and the chance to get to play with free hardware.
Awesome, cool. Before getting into robotics, because we're going to get into robotics, I was going to actually ask you another thing, because I know that you've also got another identity, or maybe it's not really an identity, but it's something really cool that you've got under your belt. So you're one of the only ones that is actually keeping, or no, I shouldn't say that, sorry. You are the reason why Pebble is still alive, right? Tell us about that.
I am not the reason why Pebble is still alive, but I am involved in the reason why Pebble is still alive. So yeah, so what you're referring to is Rebel, which is a group of, there's dozens of active participants and hundreds of supporters. But yeah, what happened was I was extremely involved with Pebble. I absolutely love Pebble. If I give you a little tour of the office later, I can show you there's at least half a dozen Pebbles within reach right now, and there's way more than that in general. But I was I've every single Pebble opportunity I've been given, I've taken. So there was a Pebble hackathon in Boulder, Colorado. I'm from Ann Arbor, Michigan. If you're not familiar with that geography, it's quite a trip. And so but no problem. I'll drive to Boulder, Colorado for a Pebble hackathon. I'll drive to Ottawa, Canada for a Pebble hackathon. And I was involved with every single program that they had available for developers, and I was obsessed with Pebble. And then in December of 2016, or even before that, there started to be rumors that maybe Pebble was in trouble. There were some layoffs that kind of confirmed that. And then finally, actual substantive evidence that Pebble was shutting down. And within 2 days of that news, we had created a website and got organized and started backing up all of the documentation and software that we were able to grab, the SDKs and things. And there was a bunch of people working on different ideas, and we kind of organized under this masthead called Rebel. And since then, it's been 3 years and some at this point. But we've, I say we, Catherine Berry, who was Pebble Emeritus, almost single-handedly replaced the back-end functionality required. It may seem strange because you think this is just something on your wrist. Why does it need anything online? But all of the weather services and dictation and things like that do require back-end services. And Catherine knocked all that stuff out in a span of a couple of weeks while she was between jobs. And then we have other volunteers. There's people working on firmware, replacement firmware for the watch, because that is all closed source, so we don't have any existing code for that. That's coming along really well. And we have even people that provide tech support. Like we're almost like our own little company. Well, we are a company, but we don't pay people. but we have like a Discord with people standing by for tech support, and I actually spend quite a bit of my time answering support tickets, and yeah, that's Rebel.
That's really cool. I mean, it's as I said, it's amazing to see, you know, something like a piece of technology that was kind of almost running out of time, that then got recovered and got actually activated again, and now
Yeah.
there's a massive community of people. Do you have numbers around like how many people are actually kind of developing or participating in the community now?
You know, I wasn't planning on going into this, so I don't have current numbers, but I mean, I can tell you that the number of people who have paid at least once for a monthly subscription, that's like a 5-figure number at this point. Number of people who have hit our APIs at least once, meaning, you know, they used Rebel Web Services, that's a number in the 6 digits. The number of developers, we recently, that was actually one of the things that was lagging, is we replaced everything for the consumer experience as quickly as possible, but the developer experience we hadn't focused on until recently. So the App Store was actually frozen in time for several years, but we recently added that functionality so that people can start adding apps again. It's still a bit of a manual process. It's not the same as Pebbles was, where you could just automatically upload your own apps and update them anytime. But we actually have new Pebble apps in the App Store now, which is ridiculously exciting. And I mean, the number of people working on new apps is in the dozens. The number of people working on firmware and replacement mobile apps, that's going to be in the single to double digits. But yeah, the number of people it's impacting is in the hundreds of thousands.
That's awesome. Really, congratulations for that effort and for keeping it ongoing.
Thanks.
Right. So now it's time to actually talk about what we came here to talk about, robotics. So I'm excited to know about how you got into robotics and what made you kind of decide to actually try it out yourself.
Yeah, well, familiar story from earlier. I mean, I was always very interested in. I feel like you know, a decade or two, there was a lot more hype about robotics. I would say the first robot I bought was, I didn't bring him to this, but the first robot I owned was a Sony Aibo. So I've had a robot around the house for, you know, decades. And he's like a pet at our house. That my daughters interact with as if he's a real dog when I remember to put a fresh battery in him. So that was probably the first time I was personally exposed to robotics, and I was always into little toy robots and stuff since then. But it wasn't until I developed my sort of maker skills that I could get into it. And even then, I have so many different interests that it's hard to decide what I want to focus on. But again, Hackster to the rescue. The most interesting, one of the most interesting projects I've worked on, because I'm also interested in machine learning and autonomous vehicles, was this guy here. This is Donkey Car, and this was a Hackster project. The project being focused on donkey cars. This actual entire platform was free from Hackster, so sign up for a Hackster contest and get free stuff. But yeah, so this is an autonomous vehicle, but what it's intended for is to be a race car. That's what the Donkey platform is about. It's about competitive racing. But my idea that I submitted to Hackster and, you know, won this hardware to develop was I wanted to, instead of using it for a race car, turn it more into an autonomous vehicle. And specifically, I mentioned I live in Ann Arbor in Michigan, which is near to Detroit. And Detroit has a lot of difficulty with what are called food deserts, which means people don't have access to fresh produce, fruit and vegetables. So my idea for the contest was, what if I made an autonomous vehicle that could deliver those vegetables? Obviously, this isn't big enough to do that. It's just a prototype. It did have a little shopping cart on it before. But so the Donkey Car platform, even though it's designed for racing, it's really easy to augment. There's this concept of parts. And so I added parts that incorporate. So this on the back here is a GPS sensor. I don't know how to show that easily, but this here is a GPS sensor. And then this is a 4G hologram radio. And so instead of it driving around a racetrack, oh, look, there it is with its shopping cart on top. Very good. So instead of it driving around a racetrack as far as possible, I made a prototype that drives around my subdivision, stopping to drop off fruit. Obviously, I'm not sending these into Detroit anytime soon on their own, but the prototype is something that really inspired me that I'm working on a more realistic version now.
Yeah, I mean, that's so, as we said at the beginning, that's actually how we met, right? You kind of submitted this this project, and it was really interesting to see how really like a small car, you know, of the kind of the type of the donkey car could actually be used for a social good reason, right? Or with a social good purpose. And it's interesting, you know, I find that really interesting, that crossover between technology and social good, right? And I was going to ask you, because I know, you know, we've spoken about this before. I know that you are kind of really interested in that crossover, right? In that.
So that's kind of what that's kind of what I'm obsessed with at the moment. Again, a lot of it was inspired by this concept, and just generally the notion that, you know, I do all these Hackster projects, I do all my other personal projects, but what are they for? What is the purpose behind them? And actually, thanks to you, I got to attend a keynote speech in December at the AIoT conference with William Wu from QED. And that was just like a real mind-opening lecture where he basically shared his story, how he had worked at, I think, NASA and a couple startups, you know, applying his awesome engineering skills to those. But his girlfriend or wife, I can't remember at the time which she was, but was involved with some projects in Africa, and he went over there with her, and he just told the story of how they were having problems getting data that they were collecting into a usable format. And, you know, he wrote a Python script so that it takes 30 seconds, if that, instead of 3 days or whatever it was taking before. And I just found that really inspiring, and it kind of reframed everything I do with my projects. And instead of just coming up with some abstract thing to control the ceiling fan or whatever, I'm always thinking about how can I come up with an idea that will actually help people. And this was before the pandemic, but with the pandemic, it feels even more relevant now. So that's what I'm exploring right now. I just started something called Oasis AI, which is kind of my think tank platform for all of those projects, basically leveraging AI, open source, etc., for helping people out.
Do you have a website for that? I mean, I'll let you do a plug-in here if you've got a website, I can share it.
I do. It's only on GitHub right now. I can post it later, but it's oasisai.github.io.
oasisai.github.io.
I haven't found a good domain yet, because oasis.io, oasis.ai was taken and oasis.io was taken. So
is that it? The one that you see on the? Is that correct?
Does it look like this? If it looks like that, then that's it. I can't see your screen or whatever you're showing. Oh, sorry.
Cool.
Yeah. Oasis.
Right? Yeah, perfect.
Yeah.
Cool.
So if there's nothing on there yet, but you can sign up for the newsletter and follow Twitter, and then once there's things to share, that's where they'll be. So if you're interested in this kind of stuff, please sign up there. That'd be great.
Nice. And how do you feel robotics is playing? I mean, what role do you think robotics is playing in the social good scene? I mean, is there anything that you've kind of considered? I mean, aside from the project that obviously you've built already, is there any expansions of that or any other things that you've considered?
So I think what's interesting right now is I'm really interested in machine learning. I'm really interested in autonomous vehicles. And in addition to that, four-wheeled autonomous vehicle. This is another Hackster project. And this one in particular was an NXP contest. And the idea was fighting fire with flyers. I think I said that right. I don't have the propellers on here right now, but this should look pretty much like a drone. And for that contest, I added this camera on the front, which theoretically has the ability to detect when it's looking at forests. The idea was that it would locate and create a map displaying combustible materials, because if you look at a forest, it's like green, 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 and then if there's a bunch of brown, then that's things that could catch on fire. Long story short, I think that autonomous vehicles, whether they're flying or wheeled or but just the coupling of machine learning with things that can actuate is just kind of fascinating for me right now, and seems like a way that a good platform for being able to help people with all kinds of things, whether it's the pandemic or forest fires or all kinds of social issues that we can use our engineering skills and these kind of platforms for. And this is all based on open source stuff. So for this, I took an existing platform, I just added my little bit of spice on top of it. Didn't have to do all the work of creating this autonomous vehicle or any of the software. I just put my ideas on top of it. So that's why I'm excited about applying open source software to hardware in that way to solve problems.
Very nice. So I'm going to ask you, I guess, from a developer perspective, or someone that's approaching this, both the robotics world or the drone world, what does it take to actually get into it? I mean, you were talking about open source projects. So what open source projects have you used, and how hard were they to get started on? I mean, I assume you used PX4 on the drone,
yeah.
Right? Cool.
Yeah. So
what about robotics? Did you use any open source projects on the robotics side?
Yeah. So as far as how hard it is to get into these things, I mean, I think it's quite easy. I would like to say that anyone can do it. That doesn't mean that it's not a lot of work. Like the donkey car platform, I would say was quite easy to get set up. This was a couple of years ago, and it was slightly more in its infancy, and so maybe the documentation didn't always line up and stuff like that. But I would say the donkey car stuff is really easy to get into, and there's a really enthusiastic community that will help you out as well. So, and especially nowadays, there's all kinds of online virtual simulations and stuff, so you don't need to spend $350 for a setup. And then on the PX4 stuff, again, I mean, for me, I've never done anything like this before. Like making an autonomous radio control car. I've driven radio control cars non-autonomously for my whole life, and I've even created my own sort of lame autonomous radio control cars using like infrared sensors just to see how far you are from the wall and stuff like that. So that was not a huge leap. The concepts involved in a quadcopter just in general, and then making it autonomous, there was a lot more learning for me. So there was a huge learning curve for this one for me, but it was really nothing. There wasn't like any super complicated math that nobody could do, as much as just sticking with it and investing the time in understanding the platform. And like I said, all these projects, just like with Rebel, the thing about them is, sure, there's the software, it's open source, that's great, but it's the community that is the most important part, and they all have strong communities. And so you can get on their Slack channel or their Discord or their forums or whatever, and if you have a problem, they'll help you out. So as much as it's not going to happen overnight, you definitely have to put in some work to understand these things, but I really think anyone can do it. And these communities certainly make it way easier, because people can't wait to help you get started.
Awesome. And I'm just going to share if you're okay, I'm going to share your Hackster handle there, because I'm going to say to everyone that's willing to actually give this a go, what's interesting is actually, I mean, you've actually documented these projects quite well, if I remember correctly.
Thank you.
So you can go on there and actually have a look at what David has done and replicate it. And I mean, as we were saying here, there are really strong communities around PX4, around Donkey Car, DIY robocars. So really, I mean, it's, yes, I mean, you have to put some work into it, like anything, but there are people there to help you. And there are a lot of different resources that you can get online to actually get started and do what you're doing. So David.
I was just saying, on Hackster itself as well is a great resource. In addition to my projects, there's thousands of other projects on those same topics that you can find. And so, like I said, I try to do every single Hackster contest that happens pretty much. So I'm doing 2 contests right now, And the other cool thing about those is both those contests, I'm working with people that I've never met before. So Hack's just like a cool way to pair up with people, because for both of those contests, I was like, I don't really have a strong idea that I feel passionate about for these, but I would like to be involved. And so I just kind of reached out to people and connected with a couple people. So I'm collaborating with people all over the world on different Hackster projects, thanks to the Hackster platform. So that's another way, even if you have an idea, even if you don't think you have the skills, if you've never seen an Arduino or don't know how to pronounce it, you should still get on Hackster, and maybe someone will pair up with you and help you implement your idea.
Awesome. Thank you for sharing all all these really, really interesting tips to have other people hopefully follow your footsteps.
Nope.
I'm gonna now say goodbye to you for a short while. I'll have you back on in a little while, but
great.
I'm gonna take you off for a few minutes and then call you back on later on.
Awesome.
Thank you again. Thank you, David. Cheers. So now we're lucky enough to have another guest with us. And if you were on the last call, on the last show last week, you have probably seen him already. This is Raffaello. So Raffaello, welcome.
Good afternoon. Finally, I'm here.
It's nice to see you.
Welcome. Yes.
How are you?
Fine. Exhausted, but fine.
Cool.
Finish a business call and now finally in this amazing live.
Awesome. Thank you for joining us. Thank you for coming right after the call. I know you had the other call right before this. So yeah, I really appreciate you joining us. And it's cool to have you back on the show. So you were on last week and you showed us a little bit of what you're working on. Before getting into that though, I'm keen to ask you about, again, how are you settling in your work from home environment? I mean, how are you actually, have you set up a special work environment in your house?
I know you asked me a picture, but today was really impossible. I will show you directly now what.
Sure.
Okay, where I work and where I live. If you see, this is okay. This is my desktop where I work. Here I have my 3D printer where I print my stuff. When I work on my robotic stuff, here there is my robot. I don't know if yes, okay, we can see. I have extra stuff, board. There is a jet racer. Now in stash, I will work later. My short laboratory is here. And my kitchen. This is my main stuff when in this period of quarantine.
So it seems like you've settled in quite well. Do you have, did you work from home before?
Not really. So a few times, one day for a week usually, but not really continuously right now.
Okay. And what did you find? What was your most challenging part of adapting to working from home?
I have every day a lot of meetings, working meetings. Otherwise, it's a piece of cake because I have more spare time. I can work on my project. I can do a lot of stuff. This is nice in my spare time because usually you spend time to go back home. And this is good for my project because you know me, I have a lot of projects about robotics and others.
Yeah, cool. I mean, there is a request from the audience here.
Yeah.
Can you read it on the bring back the sunglasses? Someone has been following you.
Oh, hold on. Where he is? I forget it. Ah, yes, he's here.
For the ones of you that don't know Raffaello, he's got quite a
he's
got a lot of pictures like that. So
I'm super serious.
I want to know how it got started. I mean, how did you come up with those glasses?
Okay. I made. Hold on. These glasses was found from a friend, and we found on the internet. We printed. We have a lot of picture with that. I don't know if you remember the Maker Fair in Italy.
Yes.
Yes.
Make it
three guys with these sunglasses. It's really cool.
Can you see something through the sunglasses?
Yes. I don't know. Maybe you can see some.
Oh yeah, a little bit.
Yeah, you can see something. It's more or less something like that.
Cool. Right. So that's really cool. Let's talk about what what brings you here and what brings you to robotics. So I know that. I mean, I'm going to define you as an expert in robotics. You've done a PhD in robotics control theory. Specifically, I think the title was something around inspection robots for inspection for nuclear power plants, right?
Yes, exactly. Nuclear fusion machine in this case. There was a different aspect about robotics. Part about control theory, because this was my main field during my master degree, and in a good part of my PhD, where I focus about new control models and control in a discrete time, like a computer. And during these 3 years of my PhD, I designed a robot for a nuclear fusion machine called the tokamak. Just I don't know if you know about this nuclear fusion machine is experimental. Now there is under construction the biggest one in France, but at this time the biggest active nuclear fusion machine is in the UK, called Jet Machine. Is in the south, is close to Reading, or in the way from Reading to Manchester, I don't remember which is the city.
And what are the challenges?
This little robot to inspect was experimental, repeat, is not at work. But to work inside, the gate was really little. I don't know if I have a picture. Maybe one moment, I check from my phone.
But tell us, Raffaello, tell us what the challenges were with that kind of environment. I mean,
yes.
What's special about?
Anyway, I found a picture later. I will send you, but from my phone.
Oh yeah, I can see it. Nice.
Yeah.
Really
about
robot.
7 centimeters of robot. Was with the first, I think, or second, first 32-bit ARM board for makers. I don't remember. Maybe before the BeagleBone was another famous board, not a Raspberry Pi, but another one. And the problem was design this little robot to work inside this machine. And second aspect, design a path navigation controller to the robot to move and check all parts of the nuclear fusion machine. Honestly, now I don't remember really well. I need to check again my thesis, but one of the points really where I worked a lot was the controller, the navigation controller, using an aspect about the discrete control time. And yes, I spend a lot of time to design the robot.
Interesting. So yeah, let's not get into too much detail of the thesis. Otherwise, we'd probably have to kind of.
Yeah, I don't remember anyway. I will speak something. I will tell you some lie.
No, but I mean, it's absolutely fine. I think what's interesting is how you got into the world of robotics, and what the next step, I guess. What are you interested in now? What are you developing now? I know that you are a big fan of robots in general, and you've got a couple at your house. So we've seen one last time. Actually, you just showed it to us as well. So what are you working on? What's your kind of project that you're working on? Actually, before that, I wanted to ask you another thing. The really cool thing that you're not just involved on robotics on your own, but you're actually part of a community of people working around robotics, right? It's an Italian community. And
exactly.
I want to ask you, can you tell us a little bit more about what you're doing there and what that community is called?
Our community, Italian community, is called Officine Robotiche, or in English, Robotics Factory, maybe. Is a non-profit association made 3-4 years ago. And we work about we develop robotics for fun, and we teach for school, in particular, the president now and my friends and team, spending a lot of time to the school to teach how the teacher can teach robotics, and help the school and provide material if it's required, help about competition. Example, we have friends that working in line follower project. Now I have another friend that is really in deep about the race car, and other friends that work in different aspects. And another really nice point that we are not involved, or we don't, we are not affected about the quarantine. This community and this association was born with all the team was not in the same city. Example, we have friends that live in the north of Italy, other friends that live in the south or in the center. And now we are around the world, because example, now we live in UK, another friends live in London, okay, and other live around the world, literally. And this is nice because we always share our ideas about robotics. We have different teams. One that is really focused about electronics, electronic design, other about software. Example, I'm more oriented about the software, robotic software, and I use a lot ROS, the robotics operating system. Example, my robot Panther that you have seen before there is use ROS. I made a few packages to control the robot. Time ago, with my friends of Officine Robotics, we may design an embedded control board, was called Micronav. Maybe I have something to show. I don't remember its work. Yes. Okay, I try to share my screen.
Yeah, we'll put it up. I'll put it up as soon as I see it on your.
Okay, one moment.
While you do that, I was going to say it's cool. I've met some of your friends that work in Officine Robotica. It's cool to see how many different things you guys are developing at once, and how the community really gets together to solve specific problems that others are having, right? So I quite like the community aspect of the whole working kind of across boundaries and together. So that's really nice.
Yes, we really focus. We are focused on different aspects, and depends of the field where we are great or we works well. Example, me, I like to work in high-level robotics, but it's not only the first one field about robotics, because when you speak about another engineer, going deep about physics, control is cool. But when you start to speak with a child, you want teach it about robotics, you use another vocabulary, you use another way to show how the robotics work, like the microbit. Example, the microbit is the first step to teach about software, programming, and embedded. Really simple. And this is the same story about robotics. There are simple embedded little robots to start, or a project. There are on Axter.io as well, other really nice project to start about robotics. And we use really different type of electronics. We can start from an Arduino to design a robot, or we design starting for another board, an example, an STM, if you want to go more in deep or have more power. We start with a Raspberry Pi, or we can go up with a Jetson if we require other CUDA or something else. We are really open-minded. We can use all engine or all electronics are available.
Very cool. So one thing I was going to ask you, in terms of, I know you've done a lot of training, a lot of education with your community. in terms of getting started on robotics, what would you say are the first steps? I mean, where would you go, or where would you send someone to kind of have start looking at resources and material to like get started on specifically on ROS, I guess, and yeah, like how to build your first robot?
Compared when I started to work, it was really a pioneeristic time. Now it's really simple. You have a lot of stuff where you can start. There are a lot of material where you can start, example, Arduino. Before when I started to work in robotics, I remember I used a microchip controller that was really hard to start. I made my programmer, and now it's completely different world. If you plug in an Arduino, you can literally start with an example to blink a LED. I remember the time when I talked with my friends about blink a LED. It was really hard every time. Now it's simple. You can find online a simple project. You buy 2 motors, a motor controller. You can spend. You can start from I don't know, £50 or €60, or in dollars maybe 40, because it's simple. $40 in America to build the first simple robot to work. And you have literally a lot of power. With an Arduino, you can design the first step of the robot, and after that you can use example ROS to control the robot. Step by step, you can add from an Arduino a Raspberry Pi. Now you can use a camera. The same robot, starting with the same design, you can add step by step new parts, and will be more powerful. You can use ROS example. I really like it because it's another software to is a workframe to find a good library, good package to navigation. Example, if you are a software engineer, you don't know really well how it's work navigation, you can use another software made from another university or maker or designer, a package, and you can improve this robot. It's simple and not honestly now really expensive.
Cool. So you mentioned Arduino, and then you mentioned Raspberry Pi and ROS, right? What if you were to start with Arduino to build a robot with Arduino? I guess you wouldn't be using ROS, right? So if then you move to Raspberry Pi,
it's not true. It's not true. It's not true.
Okay, interesting. So have you looked at ROS for embedded microcontrollers as well?
The point is, with ROS, you have an interaction package. Arduino can send package to ROS, and from ROS you can read these messages. An Arduino Nano or Arduino doesn't have a lot of memory. You can send a lot of messages, but this is an entry point, a good entry point. You can use the same hardware to start something bigger. After that, maybe you have a different wave. And there is another point. If you want to improve the embedded part, you can move to an STM, a Nucleo board. And with a Nucleo, you can use or the same ROS code. In this case, you have more memory. You can improve the software. Or second point, you can go to ROS2. This is the new version of ROS. In this case, ROS can work natively on a STM board. In the same case, you can have a different option to manage the robot, the low level in this case of the robot. If you're growing up, you have the Raspberry is really popular, cheaper, or the Jetson Nano are two competitive board. Honestly, in my opinion, are not the same, because the Raspberry is oriented for communication, have another power and doesn't have a GPU. And in more cases require a GPU to improve the performance of the computer vision. In this case, you can move to a Jetson Nano, and we are really spending not a lot of money. And after that, if you need more power, you can change the board. And hold on, there are sensors, because a robot is not only a a board. It's not only a board with a fan, but you need a sensor, you need a motors. In this case, step by step, you can change the sensor. You can start from a camera. Example, you buy a Raspberry Pi camera or a webcam camera, and you can move to a stereo camera. In this case, you have more information about depth. And in this case, you can recognize really well the distance. You can add a LiDAR, or you can own-made a LiDAR. There are on Axter nice project about LiDAR.
I was actually going to ask you, that's interesting. I was going to ask you about LiDARs, actually. So, you know, it's one of those things that, like, a couple of years ago was really expensive, and it's becoming more and more available. So what's your view on, you know, how that's evolving and whether that's going to become...
This is a good point. This is a good point. We are lucky because the automotive really spending a lot of money to improve the autonomous car. And this is good because a lot of companies invest on it, and the price slowly going down. Example, now there are a new LiDAR. On my robot, I have a LiDAR. I'll show you. Example, now I will show you some component of my robot. We can see here, this is the LiDAR. This was the cheapest from when I bought. Was a Slamtech LiDAR. Now is not cheapest. There are other really cheap and with a good price. This is a stereo camera. This is a Z stereo camera. This is the Z2, the last one released from Stereo Labs. This is really good because you can see the depth from an image, and the robot can build, example, a 3D map or understand where is the people on the view. But to use a stereo camera like this one, because it's completely different of a RealSense, the technology is another one. Example, this camera works well outside, really well, because it's not like the Intel camera, I don't remember, the RealSense. The RealSense use an infrared sensor to recognize the depth. In this case, this robot can work well outside, but if can't work well in the dark. Is opposite. The RealSense can work well on dark because the infrared works, but outside with the sun, the stereo camera use in this case require a GPU, the SDK, because the power to read the information from the stereo camera works on this on the core of the robot. In this case, it's a Jackson Xavier that I use. This camera use CUDA to analyze the data, and only in this case I can use an NVIDIA Jetson to analyze the data. It's mandatory for me. I don't have other option. I have, I don't know. Oh, okay. Yes, maybe you can see something else. There is on top, behind the LiDAR, the motor controller. I show you something else. Give me a while. I bring the robot. 11 kilos of robot is really heavy, this robot. Oh, sorry. Okay. One moment. Okay. Whoa. Okay, maybe we can see something more. Okay. Here we can see the truck. This is a project that I completely homemade. I spend a lot of time to design the mechanical parts because Alessandro told you that I'm a control engineer and I work in robotics, but I don't have, my field is not design, I'm not a mechanical engineer. And for me, I spend really a lot of time to understand how I can design a mechanical part. This robot is cool, for my opinion, because I have a lot of damper. You can see one here, another here, and another here. Maybe, yes, you can see something. A violet is the damper, like the same. This robot I didn't make the parts. I designed the part and I send the part to a factory to cut for me. The slide I made from scratch. It's cool because look like made from a factory, but it's not made in this case. And in front, what we have, 11 kilos is really a baby. There are other parts. Example, there is a Tensi, not an Arduino, to manage the low-level controller, because we can imagine the robot with a different layer. There is the low level to control the robot, to control literally the motors, how the motor can work. And there is the motor controller. Another controller, low-level controller, control the LEDs. I will show you later a video. Oh, there are some LEDs here. And the other LED to interact with the people, because I don't remember if I told you or last week or today, this robot is made to human interaction and navigation. And another point, this is for me a good developed base to study new aspect about robotics, electronics, mechanics. Now mechanics, no. I already studied on that. And this is another controller, just to bring again the discussion. After that, there are layer by layer, high-level controller, the Jetson, and sensor connected to the high-level controller. And
so, Raffaello, you mentioned, hey, you mentioned that you're not a mechanical engineer, but you still built, that amazing piece of engineering there. How? That's a good example where I would ask, I want to ask you, like, how did you start? How did you get into developing the mechanical parts? Like, where did you look up, or who did you talk to actually get into that? Because that's an interesting aspect. There's a lot of electronic engineers on the line here that are probably interested in building more, I guess, performant robots. How do they approach the problem? What would you recommend?
Okay, I speak how I made this robot and how you can start now to make a robot, because it's different. When I designed this robot, I was without a 3D printer, and some part of this robot was designed for a reason, because without a 3D printer it was really impossible to make strange parts or design little part of the robot. In this case, now with the 3D printer, and I started this robot in 2014. I started to design this robot. I was not really growing up the 3D printing. The first Maker Faire in Italy was maybe in the same year, maybe. And for me, it was really a nice prize to buy a 3D printer. Compare now that I have a 3D printer. When you want to make a robot, or you can design from scratch. I have in my web page. I will send you a link about my other project. You can design or really buy a wood and cut, or if you have a 3D printer, you can print the parts. To design like Panther, maybe is not require more time. Honestly, you have to use in my case, I used during my studies at university SolidWorks. But now there is a Fusion, AutoCAD Fusion, that is free for makers, and this is a really good point. You can design a great mechanical part of the robot without spending nothing. There are other tools about the mechanical parts, but I don't remember. Fusion, I like Fusion. I'm studying now and convert my project Panther from SolidWorks to Fusion, because now I can't work with Fusion. Sorry, with SolidWorks. And there are other free software for mechanical. I don't know, but there are needed sometimes other software to design the electronical parts, because when you design you buy the Arduino, maybe you want to connect all sensor to the board. There is KiCad, another free software that you can design the part, or you can buy, or you can make from scratch, or you can send in China and buy the PCB. In this case, are not really expensive like years ago. Is a piece of cake, honestly. And electronics, mechanical, software. Okay, you can work on Linux. I prefer Linux, but ROS work on Linux. Arduino is for Windows, Mac, and.
So what's interesting is, I mean, I guess there are different layers. You were describing the actual physical layers of the robot, right?
Yes.
There's also hardware layers, and then there's software layers. And you know, if we talk about ROS, there's a lot of different layers in ROS itself, right? So I think we probably need to have another episode on actually how to get into the software development, because I think that's a whole new topic.
Yes. So maybe we can find nice free software to design a robot, because really is simple. I remember when I started during my childhood about robotics was really difficult, really difficult. Now it's amazing.
We have a question from David, actually. What is like, where do you buy the mechanical parts like springs, threads, wheels, LiDAR, etc.? Do you have a specific place where you go to buy this stuff?
Okay. In my case, for Panther, I start to find online the components needed for me. Example was a mess, because the robot, the truck, the truck, yes, you can see, is made with the imperial units. It's not in a SAE matrix, because the components, example, the gears, I bought from an American company. It's called Action Robotics, maybe. I don't remember well. Anyway, this was American. I didn't find nothing in Europe with a really nice design for the clamps, gears, chain, really amazing. The body of the robot, in this case, is in matrix, because I found a Netherlands company called Microbeam. Maybe it's really dark. I don't think you can see something. But this part are made from. I bought a few parts from Microbeam. The plastic I design in this case is, and I bought the part, and I send my CAD part to the factory. Sensor, RoboShop.
Do you have everything, Raffaello? Do you have everything online on your page?
Yes.
Okay,
And it's not updated. I will send you a few links. I start from my website, first point.
Yeah. So if you tell us the link, we can share it on here. So
yes, exactly. Because
yeah, go on. I mean, you can either share it on the chat, or we can.
If you want, meanwhile, I can share. Give me okay.
I'm also aware that we're at the top of the hour, so we're gonna have to close off soon. But I mean, this is really interesting. Yeah. I think, Raffaello, I'll bring back David in the show again. Hey, David.
Hello.
And I mean, it's really interesting. The reason why I wanted to have both of you on the show is because there is different aspects and different ways you can kind of approach the problem of robotics, or not the problem, the whole robotics topic, and you could come at it from different experience levels, and it's interesting that there is something for everyone, right? And you guys all mentioned different projects, different things that you can find online, and as Raffaello was mentioning, there's way more projects online today than there have been, right? So if you want to get started with robotics, with ROS in particular, there are a lot of projects online on Hackster and on other sources. There is obviously the ROS community that's very, very active, and you can get a lot of projects on there. I actually think we should probably have another show at some point on ROS and actually get in a bit more depth and understand how you can actually get started on robotics with ROS. It'd be cool to actually have a bit of a walkthrough and be able to really build something together. So I think it'd be fun to have a ROS development and maybe even PX4. Maybe it'd be nice to get some PX4 development going as well. So it was really cool to have you both on the show. Thank you for joining me and sharing with me your experience so far and what you've been playing and developing so far. And hopefully there'll be more reasons to call you in the show again and to talk more about robotics. Do you have any last words that you want to share with the audience?
I really spoke too much for me.
It was great. David?
Yeah, I don't have anything exciting to add. I guess just check out my website, ishotjr.com, not because there's anything interesting there, but just because it'll help you find my Twitter and things like that, where you can get in contact with me if you do have questions about any of these projects or any of the other things I work on.
Awesome. Guys, you have your cup of coffee or beer or wine or whatever.
Yes. I specifically chose this cup of coffee today because it says iShotJR on it.
Oh, nice. There you go. I've got this one because I'm a bit of a...
Bring mine. I don't know what I will take later, I think.
It's only 1 p.m. here, so I'm still on the coffee at the moment.
Very good.
It's empty.
Oh, there you go. You can fill it up later. Cheers.
Oh, yes, for sure.
Cheers.
Thank you, guys. Have
Bye.
fun. Bye-bye.
Thank you. Bye.
Bye.